Hello, everybody.
Hello.
How are you?
Good. Hello.
First time at Aruba Networks. How does it feel?
Awesome.
That's pretty good. I think Greg did a good job. Orange laptop covers. That's pretty good. There we go. We have an orange T-shirt there too. So we're the guys with the orange color, but we do a little bit more than that. We've been in the wireless LAN industry for about 10 plus years now. Same team who founded the company. One of the guys who founded the company is actually here. Going to be opening up with an interesting talk on evolution of access networking. I know that many of you are interested in data center, virtualization, etc., but there's some interesting stuff that's happening in the access network as well. So we thought that we would poke your brain about it, get your feedback, see what you think. And in addition to just talking about networking and flows and VLANs and design, IP design, etc., we thought that it might be a good idea to talk about policies as well. You know, when you talk about access, usually the next question is who's going to access and what is going to access and when is going to access. So there's a lot of questions around policy. So we have Ashwath from our ClearPass policy management team. He has been part of the Avenda systems, which Aruba acquired 2 years ago?
Yep, 2 years ago.
So, and we quickly, very quickly integrated into the Aruba brand. And, you know, ClearPass has a kind of multi-vendor DNA already baked in. So it was relatively easy to do that. Myself, I'm Ozer. I'm part of the product marketing team. I paid, you know, I work with Steven to put these events together. We worked on wireless field days many times, but we thought this year maybe we can focus on networking field day. Okay, so brief history on Aruba. As I said, 10 plus years, focused on wireless networking for a long time. The major milestones, 2007 we went IPO. Around 2008, 2009, 11N technology came along, which made Wi-Fi really important. And then the iPad came along, which made Wi-Fi really, really important. So I would say 2009, 2010, the company really started to grow. So that fast, accelerated growth for the company we have seen during the last 5 years. Founder of the company is still here. Many of the founding engineers are still here. We like to operate like a startup, although it's a 1,500 plus company. We work on wireless LAN solutions, remote access solutions, policy management solutions with ClearPass, multi-vendor network management with a tool we call Airwave. Some of you might know Airwave. Recently, we acquired a company called Meridian Apps to offer indoor mobile engagement services and indoor wayfinding. They're actually a mobile app developer as well. So we're trying to add more mobility services on top of a solid foundation of access networking products, if that makes sense. So that's kind of quick history and where we're going. All right, so with that, I'm going to hand it over to Partha so that we can talk about more interesting things.
Good morning, everybody.
Good morning.
My name is Partha Narasimhan. I've been here with the company since the beginning. I see myself as a problem solver. 20 years ago, or 20 plus years ago, I looked at wireless networking as an endless source of problems. Right, that I can never run out of problems to solve over here, and it actually is more true today than it was 20 plus years ago, so I don't ever regret having made that choice that many years ago. I'm here to talk about what has happened in the recent past. I mean, especially what Ozer said about the iPad is true. Even though Apple introduced the iPhone's property was that most of the time, primarily at near the beginning when it was introduced, most people tended to use a cellular interface for networking purposes, right? Web browsing, whatever apps that they want to run. The iPad was the first device where most of the initial iPads that were sold did not have a cellular interface. So Wi-Fi was an important interface. Wi-Fi was the primary interface on the iPad, and that changed lots of things for us here, as well as the industry as a whole. So we'll talk about some of what we've observed in the recent past and project forward to where we think we might be going. So I'm going to talk about where we were before. So for a while, networks were run that, the game 20 years ago was segment and optimized, right? You don't want to have an endless broadcast domain when networks were still using shared Ethernet. And so we came up with the construct of VLANs to try and segment the network. And VLANs suddenly started being used everywhere. So there was the PC VLAN, and then voice devices started getting added. Voice over IP came in, and we said, okay, those guys have to go on their own VLAN. When wireless started, we had wireless getting their own set of VLANs. Then the guest users came in, and we said, okay, let's assign them another VLAN. And then with wireless, the recent BYOD phenomenon, there was BYOD devices, and then we were worried about, okay, are these devices that are connecting to our network in a good enough state that I might have to quarantine them, make sure that we run through the checks before we allow them into the regular network. So the VLAN started proliferating a lot. And in some sense, when we first started deploying Wi-Fi networks 10 plus years ago, around the time when Aruba was still young, or maybe even a little earlier than that, some of the early adopters of wireless LAN just took the constructs of these VLANs and overlaid them onto the wireless side, and then they figured a lot of problems came up. One of the first things is that the thing that wireless allows you to do is to move around and stay connected to the network. And as users moved around a large campus, how do you make sure that they stay connected without dragging the VLANs all around? And that's exactly what we were told not to do, right? Keep the VLANs contained so that your broadcast domain and other things are fairly contained. And this took us in a completely opposite direction. But if you look at what is happening now, the world is vastly different than it was when we first constructed this VLAN-based design, is that most of the access today is wireless. Right? I have 3 devices in my backpack every day, and not a single one has an Ethernet port. So there's nothing that I can plug into. Wi-Fi is how they access the network, and that's true of more and more devices. I mean, there's devices around on the table. At least half of them don't have an Ethernet port. Right? So wireless is becoming the primary access. The devices have become more complex. So where we used to have a voice over IP phone and put it on its own voice VLAN, and we could say that, okay, there's only one thing that it does, which is voice calls. Our devices, even the smartphones, have become so complex that they can do many tasks at the same time. And so something like, you can make voice calls, you can do Link or FaceTime on your device, as well as email and other apps in there. So a single device, it's become a multi-purpose device. It's not made to do one thing only. So that was one of the changes in here. The biggest other trend that we see is that if you tell users that you can do your work anywhere you want to, chances are they will attempt to do it. I mean, so the connectivity and the kinds of things that they want to do is no longer constrained into one physical space. So there's location awareness that comes in. So because there are some instances where we might have to, allow or deny access to certain resources based on the location of the user. The common example that we encounter is in the financial sector, where there are firms that do banking and investments and so on, that there are certain floors on which you can't have access to certain resources. So we need to know that a user is on a certain floor and change the policies dynamically. So it's not that, okay, it's the same user, same device, they just walk down the staircase one floor down, and suddenly the network has to recognize that and do some things differently. So mobility not only creates the fact that the network's getting reconfigured dynamically on a very short time scale, but it also is changing things in such a way that things that were easy to do in a static world, where, okay, if I walk down to another floor, I'm not carrying my desktop PC with me, so it was easier to implement over there. Now with the mobile devices, it's getting a little more complex. So that is one of the things the trends that has happened. And because users move around and they start various applications at various places, you can't pre-configure the network and say, okay, I want to put voice on this VLAN, which means that when the user goes to the other end of campus and begins a voice call, I need to drag that VLAN around in here. So the flows are getting more dynamic as well, right? We need to recognize the fact that sometimes the network topology changes not just with mobility, but also what people do as they are mobile. And the kinds of applications are exploding. It's not just, it used to be client server, but now there's the cloud because all of the servers are moving to the cloud. There's lots of peer-to-peer applications. Sometimes the peers are on the same campus, sometimes they're off campus. So it's not even that I can say, okay, it's a link call and it always behaves this way. I need to know what the endpoint on the other side is. So there's lots of optimizations that we can do based off of what has changed in the recent past. And some of what we did, there's parallels here between what we did early in the wireless LAN space at Aruba versus what the data center guys have built, right? The complexity is so large that if I deploy a large campus like the one that Microsoft has at Redmond, how do I make sure that things are consistent across such a large physical space? Because I need access points where the users are. But the users also move around. It's not that, okay, I can say Partha's office is over here and that's the only place he connects to the network. That's how the wired world was. So to deal with this complexity, we actually did very similar things on both the left and the right? So we built this controller-based architecture where we recognize that it is very hard to integrate mobility and quality of service associated with the mobility into the wired network, into the wired fabric. So we built an overlay solution where we said, okay, abstract all of the complexity into a controller, keep the access points where the users are, but anchor all of the state at a controller and build an overlay network, right? And then let the overlay manage how traffic flows around. And it's not that dissimilar from what happened on the data center side, where again, keep the intermediate fabric fairly simple, but abstract the complexity that allows you to now do more complex things in a much simpler fashion, rather than trying to solve it in the networking layer. Right? So the trends are very similar over there. And that's what we did with the wireless LAN overlay. So this is how the world was before, where all of the VLANs got dragged into every access point, every port that an access point plugged into, so that as the user moves around, we can keep things consistent for the user. And this is what we evolved to on the right, where a lot of that state got anchored at the controller, and the intermediate network was mostly being used to tunnel traffic between an access point and a controller. So as a client moves from one access point to another, sorry, thank you. It's irrelevant what access point, what VLAN an access point is connected to, because the state is actually anchored at the controller. And as it moves across buildings from one end of the campus to the other, it's very easy for us to maintain consistency as far as the client is concerned. It doesn't see differences. It doesn't look at the fact that every floor in every building has its own VLAN, and that became less relevant. Right? And we'll see more and more of that as we move forward here. So the VLAN model is not very good for Link. Link actually has 5 applications inside of one, right? There's voice, there's video, there's screen share, there's IM, and then there's file sharing. And if you just use VLAN as a construct to segment according to traffic types, okay, what VLAN does Link go into? So that wasn't a very good fit in here, because now you got to recognize that within Link, there's 5 different applications, and look at each flow and say, okay, this flow is carrying voice packets versus the other flow is carrying video, and deal with them separately. Quality of service is actually more important on the wireless side, because in spite of all of the advances that we've had on the wireless LAN side, we have 11AC that went past a gigabit this year. It is still a shared medium, right? So not only is it a shared medium, it runs in the unlicensed band, so which means that somebody that wants to warm up a cup of coffee in the microwave is going to actually cause interference, reduce the capacity that you have. So the capacity, the available capacity itself is changing with time. And now we could go in and do a very good job of making it uniform. I would deploy APs in a uniform fashion, so every 30 or 40 feet I have an access point, but the user density and the traffic density is not very uniform. Right? As the users congregate, like we've all congregated here in this, and as we disperse, suddenly the traffic goes away here, right? So it's not even that the user density or the traffic density is not uniform, it's not even constant in time. I can't even say, okay, this area, there's more people here, but that's not true all the time. So lots of things are very dynamic in nature, And which is why we need to identify every single packet, what it is carrying, and make sure that we handle that correctly. And to do that based off of, okay, tag it as a, this VLAN goes in here, and I look at the .1p tag and say that, okay, that's what I need to deal with, doesn't work for link when multiple traffic types are aggregated into the same session. The other thing we encountered with Bonjour was Bonjour. If you look at Bonjour, it actually is a very simple protocol, and it uses multicast discovery. So if devices are all on the same VLAN, you just ask and you just put out a packet that's saying, I'm looking for somebody that can support AirPlay, and back comes a response. Right? There's no reason to set up some central coordination server that tells various devices where other resources are. It actually works really well at home, in home environments, right? But when you bring it over to the campus environment, lots of things break down. If you look at the home environment, it actually is characterized by two properties, right? One is most home environments are very simple, single broadcast domain. There's one router, and you connect it in there. There's a single VLAN. So you put out a multicast packet, every device at home is going to pick it up and then can respond. Your home environment is also characterized by the fact that it is protected from your neighbor's home environment, right? So even though you could share the same Wi-Fi channel, their broadcast domain is different from yours. So you don't see their devices and they don't see yours. When you bring your 5 or so devices onto campus, both of these break down, right? You're no longer just in your own protected home environment, a single broadcast domain. Your devices could end up on multiple network fragments. But more importantly, there are other devices that you don't have any use for that are also ending up in the same broadcast domain as yours. So both of these kind of break down. So the conventional response to link to Bonjour was, in many campus networks, they just turned it off because it did not scale, it did not work. The cost of propagating broadcast multicast on a wireless link is extremely high. So the biggest response was, okay, turn it off, we can't deal with this. But back came feedback from the students saying, what do you mean? These things work on my $50 router at home, and you guys are telling me it can't work here, right? So this is what we were faced with 2+ years ago, and we said, okay, why don't we look at it and solve it the right way? Because the first reaction was, okay, why don't we just propagate all these broadcast multicasts across all VLANs? And that actually makes the problem worse, right? Instead of discovering 200 devices and searching for yours and maybe finding it or maybe not finding it, now you're going to be left with 20,000 devices and trying to search through that for yours. So we took a look at it and we say, okay, the idea is to actually construct a solution where you recreate the home environment, the environment that the user had at home, but do it in such a way that you don't go make whole-scale changes to the physical network. So can I now build an overlay, a topology at the virtual layer, a virtual topology, such a way that a user only sees what is interesting to them. And what is interesting to them depends on who the user is. A user gets to see all of his or her devices, wherever they are on the network, wherever the devices are on the network. The user can also be enabled to see devices that are around them. So location is becoming an important construct, right? So I'm in some building that I'm not very familiar with, and I want to print a document.
So you're classifying Bonjour traffic based on AP location, right?
Well, the device's location, which depends on the fact that, okay, if I'm connected to this AP, chances are I'm close to it, but we can also narrow it down to something much more granular than an AP location. But I know where the device
or wherever,
is.
yeah, I mean, if they're you should be able to tell if they're in the same building as a conference room that has...
Correct. Right. So if this conference room projector was discoverable by Bonjour, the fact that I'm here and my iPad is here, when I open it up and say, okay, what are the possible choices I have, I can restrict it to what is around you, right? So a user's location becomes important. A user's role or who the user is could become important, because we've had some cases where schools come in and say, look, I don't want the students hijacking the projector in the classroom. Make sure that the projector is available just to the teacher, right? So who the user is. So even though there's 30 students in the class that are also located close to the projector, now I can go in and say, okay, I only want to make sure that the teacher gets access to it, but not the student.
Does this take provisioning, or is this zero touch?
No, this is zero touch.
Okay,
So
cool.
that's the whole point, that The rules of what is in a device's neighborhood are now dictated by other things rather than how they plugged into the network. I can't say that, okay, these devices have to see each other now, let me put them into the same VLAN, but what if I move over here, and Ozer has nice pictures in the slide, that as I move from my office to the training room, do I change VLANs because now suddenly there's a new set of devices that are going to come into my neighborhood that should be visible to me, right? And now I have two circles in here that the only way to actually make it work is merge the two circles together to make them one. But this is just a single user. Think about thousands of users and how are you going to merge all these circles at a networking layer? So the conventional networking solution is a little hard to solve this problem with. And as I move to different environments, here is my device that has one set of neighbors because of some property, because it's a set of devices that belong to me, but it also has another set of devices that have to be in my neighborhood because I'm located close to them, for example.
So the short summary is VLANs don't work.
Correct.
We got that.
Well,
I'm fine with that.
well, that is one, right? But I'm actually making a different case that if you look at what has happened over here, the virtual topology, the rules of the virtual topology are now determined by rules that don't necessarily have a networking construct associated with them, right? I am saying my devices should be visible to me at all times. So I could be at one end of the campus, but I'm only going to see my devices in here, not what else is around me on the VLAN that I'm plugged into. And this is sort of starting to look like, okay, the data center picture where there's all these virtual groups that are being managed by rules that are specified from somebody else, but on an underlying physical infrastructure. And the significance of the physical infrastructure is becoming less important because I can come in and overlay some of the topology that anybody wants me to.
But a few slides ago, you had your overlay tunneled back to the controller in the data center.
Right.
And with AC and bandwidth increasing, is that changing for you guys at all?
No, so a good question. This actually came up 5 or 6 years ago when we transitioned over to 11n2, right? 11n got us past 100 megabits psychological barrier, and now AC is getting us past a gigabit. So there's two things to remember. The fact that I have AC got to more than a gigabit a second by partially, somewhat of cheating because I expanded the size of my channel, right? I went from 40 megahertz to 80 megahertz channels. And then I do MIMO to get me past a gigabit a second. Two things to remember. One is the amount of spectrum that I have available to me is constant. So even though the speed at which a single client actually has suddenly increased, and probably by a factor of 3 or 4, I'm still limited by the same amount of spectrum, right? So that hasn't suddenly increased. So everybody cannot all send me packets at a gigabit a second. So there's some limitations over there. Where I used to support two channels, two APs that used a 40 megahertz chunk here and another 40 megahertz chunk here, now I'm putting the two together, right? So that has some limitations on, while a single link can burst at past a gigabit a second, the sum total of traffic doesn't change.
But I'm saying, if you have a stack of switches or what have you, it's plugged in, and the uplinks, again, maybe they're not 10 gig yet. There could be, a bottleneck if you just have peer-to-peer in that local closet, right?
Correct. So I have a slide to address that. That's a hold that thought. That's an important example there. But the 1 gig or the 10 gig bottleneck itself is important because it prevents me from being able to burst at the same speed as the Wi-Fi link is. So if you haven't upgraded your wired network past a gigabit, now you're suddenly faced with an inverted problem where the wireless link could potentially be faster than the wired link, right? We've never assumed that scenario. Every time we design networks, we'd always assume that, okay, the funnels getting wider as we go deeper into the network. The speeds are increasing and so on, right?
But the bottom line is, just to clarify, so the architecture is not changing with your new APs. The controllers are still going to remain in the data center?
That part of it, the physical part of it isn't changing. Okay. But we're changing things in such a way that now I have the ability to dynamically overlay any topology I want, including not just groups of users, but go back to your thing of saying that I can actually do that for individual flows. So I'll just skip past this slide, which just talks about,
OpenFlow.
I can't statically build a network and assume that things are all going to be There's a lot of dynamism in the wireless LAN in here. But to get back to your thing, where, again, this is a slide that says I'm building a personal LAN because I'm trying to abstract what a user had at home and trying to recreate it without making changes, vast physical changes in the physical network. And that's something that we see happening here, because as a user, I only care about, am I able to do the things that I want, right? Do I know that the cell tower near my home is up and running right now? And I don't care, I'm not there right now. But I know I'm here and my cell tower here is up and running, right? So to go back to your example, I'll just fast forward. There's a bunch of things in here and I'll explain. One of the things that we do know is that, okay, if I have the ability to identify certain flows and I can recognize that there's two people that are calling each other and they're physically close to each other, which means that if I just trace the shortest path networking wise, not from the way subnets and other things are lined out, then I could potentially find a different path. I could find an alternate path between the two users. So in this case, so here's a user that's calling another one, and they are physically close to each other. Physical proximity. Here, if I have the ability to identify this flow, right, then I can now go in and program an alternate path that goes through the intermediate network without getting into the data center and the router behind it. Chances are, if one of the other endpoints is a wired network, it even has to go past a router behind the controller.
In your example, you're assuming, I guess, Aruba Wireless and LAN?
We are assuming Aruba Wireless, but we're assuming a programmable fabric in the middle.
Okay.
Right? So things like OpenFlow probably enable us to do something. If we don't have the ability, if we don't have the liberty of that thing, then we can tunnel through whatever we can. I mean, I kind of use this analogy. So we could potentially be living in an environment where there's lots of islands.
Right.
But as more and more devices become programmable, the water level is going to go down, and then we get the land mass will increase. But looking at a world where we don't need all of it to be OpenFlow and be programmable, but if I have the ability to program an alternate path, then we will take that. Because
so is this still a vision, or is there something that's actually been tested? And it's not slideware, but it's not release code either. It's sitting in the middle, right? We actually had worked with Arista to build a demo earlier this year. Arista, you said?
Arista.
But what about for campus network? Is your target? I'm confused, I guess, on that.
Well, this is to actually build it out, right? So we did this early this year in February or March to convince ourselves that, okay, there's some value here, and we are in the process of building this framework out so that, one, I'll be able to recognize these flows that can benefit from an alternate path.
Sure. And
two, then work with the switch vendors to see how much programmability I can get to overlay this on an alternate path. So it's true, those are the two components in here. I have to first recognize that there are some flows that can benefit, because I just don't want to do it if the total session is only going to carry 10 or 15 packets. I need long-standing flows that need some quality of service, or it's a peer-to-peer flow that's sending a lot of traffic that might benefit from just an alternate path.
I mean, the importance this is something that has struggled pretty badly in the wireless market. Traffic line. So you tunnel everything today. So you've already got this immediate consistency in the state distribution, right? You don't push anything to the edge, and that's fine, because 9 times out of 10 the alignment of the traffic is north-south, right? Everything goes to the internet. You're not sending 10 gig to the printer sitting next to you. There's no, it's not the data center east-west problem to disaggregate at the edge. But the problem is I can't take one access point and put it into another. They're all the biggest mousetraps on the planet.
Right.
If you don't do that, somebody will.
Well, so the thing here is that, okay, the important thing to remember that even though I can now switch this flow direct through a different path, one end of the connection is actually a mobile client. So potentially I could pick up my phone and speak on the phone and walk around with it. So what we are getting to is that I need that state anchored at a controller so that I can maintain consistency, but it doesn't also mean that all the packets have to go through the controller. I have the flexibility to say, okay, I could actually overlay an alternate path for certain types of flows that could benefit from them. And if it's north-south, it's anyway headed that way. What do I lose by just sending it through the controller?
Yeah, I mean, but as bandwidth for your largest of the large campuses it's kind of irrelevant, right? They're fiber rich, scale out, throw more links at it. I mean, I think they'd rather more features. I know from my perspective, I'd rather features over, trying to conserve bandwidth or offload and bypass because you've got a significantly easier job than the wired network, right? You already have control in the data plane.
Yeah, yes and no, in the sense that, okay, mobility does complicate things. Remember, I mean, this is, at one end of the link is a wireless link, right? So I do have to know that sometimes as capacities on that go up and down in reaction to other things that I have no control over, I need to have some context on what I'm carrying so that I can now prioritize the things that are important, get through first, while if your email is late or your iCloud backup is late.
You already have that, and that's why policy on wireless is significantly better than the wired.
Well, correct. I mean, we already have that information.
Classify it and roll code to do it, right?
Exactly, because it goes through the controller, right? But sometimes I don't want all of the packets to go through the controller because I do want the benefit of being able to cut through, switch it through, but I still need to maintain the state just in case somebody picks up their phone and walks around, right? So I have that state that user is on a call, and that is how I made that path. I need to redo the path as a user walks around.
And then your remote sites, obviously, you don't want to trombone traffic back centrally.
Correct. I mean, we have the ability to not deploy physical controllers in there, but there's still the controller functionality is in there, but it's just abstracted into access points and so on.
So you're talking about the ability to basically do local offload from the APs without coming back, flowing back through the controller, but applying the same policy that the controller would if the traffic was traversing it.
Correct. I mean, well, the controller knows what it is actually offloading off into the intermediate wired network.
Right.
I need to maintain that state, but 2 or 3 years ago, we were in a state where everything had to go through the controller. And now I'm saying I'm getting a little more flexible because I can recognize that some things can benefit on an alternate path, and I don't need to see everything that I need to see. I need to see enough to maintain state that allows me to keep that flow consistent, even though the packet doesn't flow through me. Because if the packet flowed through the controller, there's very little work that I need to do as a user moved around. But if I've offloaded that flow onto the intermediate wired network, I still need to remember that, and I still need to maintain that context.
And you can't plan on backhauling through the controller in the 11AC world anyway. You just can't bring enough bandwidth in the controller.
No, I don't think that is ever a problem, because as the bandwidths go up, we build AC APs that allow us to process more traffic.
The controller though would have to get very large for that.
Correct. The controllers will have to scale up.
You've got a significantly easier job because you've got 2 to 4 ports on the edge that you're having to worry about maintaining wire at, as opposed to 20 to 96 ports, right?
That is true. So we still have to, to answer your question, we'll keep upgrading. Like this year, we built controllers that can scale up to 40 gigabits of encrypted traffic, right? And that, as the chips keep up pace, that's something that we'll continue evolving because.
Yeah, but then you're still burning a lot of uplink, capability, right, from a closet or even from a WAN site. Right, across some infrastructure to run it through the controller just for policy applications. So, I'm agreeing with you. You guys are doing the right thing, and unfortunately, not everybody has, tunnels full of fiber everywhere. So,
I don't know. I agree. It's
latency too, right? If it's sensitive.
Well, they should be offloading.
Yeah.
Well, but that's where we get the flexibility now.
Yeah.
If I'm comfortable, I looked at the first few packets in there, and I'm going to allow this thing in there. Okay, I can offload it because fine, I don't need to see the rest of it.
Yeah.
And as long as I have state that can keep it consistent.
So while we're on AC, something I've been pushing back on would be going from 1 gig to 10 gig just because it's AC. It's ridiculous to go start stacking wiring closets with 10 gig south ports.
Right.
Just because you've got AC in there. Well, what kind of utilization? Are you seeing anybody even going over 1 gig on your early stuff?
Well, I'll tell you my opinion of that thing, right? So AC, while in theory allows you to today go past a gig, in theory, if you built everything out, 8 spatial streams and 160 megahertz channels and so on, you can get close to 7 gigs. But okay, let's look back at what happened with 11n. 11n had the ability to go 4 spatial streams 4x4, but nobody ever built those devices, so everybody stopped at 3. And in fact, the handhelds, the tablets all stopped at 1. We think a similar thing will happen, but there is one difference with AC that didn't occur with 11n, which is that with 11n, if you have 2 devices talking to each other on a link, I could build a lot of complexity in a 4x4 4 spatial stream at the AP, but if the client was a smartphone that did only 1x1 20 megahertz, I am down to his capabilities, right, for the duration that I speak to this client. With AC, we've introduced this thing called Multiuser MIMO, which allows an access point to simultaneously transmit to multiple devices at the same time. So I don't need the client devices to keep pace with me in terms of building complexity. They could remain simple, and I could collect 3 or 4 of them and say, okay, I'm going to utilize my channel to transmit more data than what is possible with 11n. Right? So that allows me to now build arbitrary complexity at the access point and gain capacity, which was not possible with 11n. That is one place where you might actually now see that, okay, maybe even if the tablets or the smartphones never get past 1x1, because we do have 11AC smartphones, they're still 1x1, you could potentially get multi-user MIMO to work, which means that I could saturate at least the downlink part of it, right?
Well, yeah, we're the workloads. I mean, all applications are built for horrible carrier networks, wireless networks, right? So, are you seeing any applications that are coming close to stressing it, other than maybe? I mean, obviously Netflix is the only thing that comes.
Correct.
Close
I mean,
to it, right?
the video has been the biggest part. That actually is. I think even the carriers are recognizing that it is suddenly defeating some of the oversubscription assumptions that we used to have. Right? The oversubscription assumptions were based on the fact that lots of traffic is very bursty, and I could just fit it all in different gaps that exist. But video is not very bursty. It tends to have some sustained, average load, and then every now and then, there's these iframes that come in and burst at a higher rate. That is starting to now stress. I mean, we are starting to see that even on the, mostly in college campuses, right, where the kids live in dorms. That is their home, so that's where they're going to do their Netflix and other things. It's less of a problem in enterprises. We are starting to get to a point where, okay, as it is, my wireless link is somewhat constrained, and now I can no longer make these oversubscription assumptions, saying I have a 150 megabit link on the Wi-Fi side, but that doesn't mean that I can fit that many users possible, because the moment 1 or 2 of them start a video, my utilization actually goes up, my headroom starts to go down. So that is one factor that we're seeing where you could potentially start to saturate some of the links. But my bigger thing is in the interim period, even though we've all released 11AC APs, most of the clients today are 11N. I was a little disappointed that the iPhones didn't have AC, which means that for another year we're going to have lots of iPhones that are still going to be 11N. Because 11N cannot do the wider channels and so on. So if they connect to 11AC AP, they're still only using some of the capacity, some of the spectrum in there. But AC means AC APs can also share the spectrum in a more intelligent fashion. So some of it will get filled in because other access points could use the remaining spectrum. So for the first year or two, your gigabit Ethernet port is going to do okay. When we get to wave 2, which is when multi-user MIMO is going to come in, and as a client population, in 2 years we can start to see a shift in the client population that the proportion of AC devices will start to grow. Then we might start to knock on, it's not that you're going to consistently knock on that gigabit port, right? But it prevents you from being able to burst. That's where you will start to see some problems where suddenly I can burst at a higher speed on the Wi-Fi link, but not so much on the wireless link, on the wired link. And then you might start to see a need to go up. But I agree with you. I mean, 10 gig might probably be an overkill for AC, but 1 gig is also not sufficient. So we need something in the middle. There's a large gap over there, and what do we do to fill that? So we're looking for some creative ideas there.
What about cellular offload? Where do you all stand on that now?
That's an interesting part. I mean, cellular offload is already happening with on just as a pure Wi-Fi thing, right? Just get your users onto Wi-Fi. That's one aspect of cellular offload. The second part of it is, okay, can I now make it seamless enough that as you move from this to that, you're not, today when you go to the Wi-Fi side, you're just completely on a different network. Sometimes the carriers don't even know. Like right now, my phone is connected to the Aruba corporate network. The carriers are not in the path. They don't know anything about what I'm doing on this side. But if the carriers are going to deploy or work with and collaborate with these hotspot deployments, then they might start to get to a point where, okay, I know who the user is and they're now on Wi-Fi. And that gets to a better user experience, that it's a more seamless transfer from cellular to Wi-Fi and back. That requires some complexity. It's not as much a technology problem as it is more of a business problem, in the sense that I can build a device that does Wi-Fi and that has a cellular radio, but I need somebody's permission to turn on the cellular radio. I don't need anybody's permission to turn on the Wi-Fi radio. And it's not just one person that holds the rights to the spectrum in this place. There's multiple carriers in there, and how do we sort all of those issues out? That to me is a bigger headache than the technology. It's easy to build the technology.
Oh, anything involving U.S. carriers is going to be a problem. So
Yes, I would agree with
that's
that.
it.
Same here.
Yeah.
Yeah.
So let me fast forward to the next slide. This is actually an interesting use case. So let me forward the animations in. So what we're trying to do here is, if you look at even the Aruba corporate network, you have the guest network and you have the corporate side of it, right? Most enterprises design their guest network in such a way that the guests are tunneled all the way out to the DMZ. So if you connect to the guest network, you're outside the firewall on the other side towards the internet. But suppose the employees connect on the good side, right? And suppose I have a projector in here, and I want to enable a guest user to use the projector, to project their screen onto the projector. The conventional networking solution is actually very hard. You have to start at the DMZ and say, okay, open up these huge holes in the firewall all the way out to the port where the projector is sitting. And that conversation is going to be very quick and very short, and the answer is no. Right? There's a reason why the guest users were sent to the DMZ, and you're not going to bring them back into the corporate network. But this, again, is a scenario where if I can identify a single flow and switch that onto an alternate path without a total network redesign, where everything outside of that flow from the guest user goes into the DMZ, but this one particular flow will take an alternate path. Right? This is a sort of a problem where it's very hard to solve it in the conventional networking solution, but it's very easy in our world to go in and say, okay, I can switch an alternate path through even the, in the worst case, to go back answering your question, what are the assumptions we make on the intermediate network? In the worst case, I could just tunnel through the whole thing. Right? So this is the kind of problems that we see that we think we can enable, because it requires knowledge of what is happening on the network, and it requires the extra knowledge that there are certain flows that can benefit from an alternate path. And then it requires the ability to go program that alternate path and keep it consistent as one or both endpoints start to move around. Okay. So this is where, I think this is my last slide, and I'll pause for questions. Where we think that the world is vastly different today because wireless enables mobility. Wireless in itself has problems, right? The microwave oven affecting your capacity and so on. But more importantly, wireless enables mobility. And the richness of the devices and the applications that we have now suddenly throw us a lot of complex problems that we think we can solve by creating and making use of the context that we have available with us, and creating a network that is programmable, that is easily amenable, rather than saying, okay, I need to build a static set of highways and let people drive on them. I can go create these highways as and when they're needed. Okay? I'll pause here, wait for questions, comments. Happy? No?
Pretty comprehensive discussion. I mean, you've covered everything, really.
I mean, is there anything that we you think we are off
Well,
somewhere.
I mean, I don't want to dominate the. So, I mean, where are you at on vendor neutral access point to controller? I mean, is that something you're going to embrace? Because I mean, that's the problem. It's weird that nobody from the wireless community isn't saying, why is this the giant mousetrap? Because you guys had a problem. So wireless had a problem to solve, whereas the wired network didn't necessarily. We've got NAC, and we've got all the other, BS that, but mostly around some security policy and management is for the enterprise. But you guys had to orchestrate RF, right? That's the fundamental problem that you all were solving with centralization. But at what point is it I can buy?
Right.
You got to commoditize the edge, or else somebody's going to for you.
Right, and I'll give you my viewpoint. I was a member of the CapWeb group with the IETF
Just
many years
framing,
ago.
right?
Right.
I mean,
So I'll tell you, the wireless LAN is still in a state of flux. I mean, this year we're going to shake it up with 11AC, and who knows what comes next, right?
But the data path, right?
Well, that and plus the radio part of it complicates things. It's no longer just, okay, I can plug it in here and I know what sits on both sides, and the cable is fairly deterministic, right? You drop a packet at one end of the cable, very, very high probability it shows up on the other end, right? Chances are. Right? That is never true with, my apologies to Einstein, but God does play dice with RF links. And sometimes they come through, sometimes they don't. The complexity of the Wi-Fi link, we have made progress. I can still remember, I have nightmares 8 years ago where, it was basic things that don't work. Okay, I set some bit on one of these packets, I don't process it right, and I sent you some response and you don't process it right. So we passed at least some of those problems. But the nature of the radio link itself, the .11 guys just drew a certain boundary and say, okay, this is the scope of what we are going to standardize, right? So simple things. The simplest example that I can use is the rate adaptation algorithm. What rate should I use to transmit a packet to a client? So as a client moves away, this is kind of like your DSL link. As you move further away, I need to bring my rate down because I can't sustain the higher modulations. Right? But how do I determine? How do I figure out, okay, what rate? That is out of scope in 802.11. So we all have our own algorithms. We think, okay, that's one place that I can differentiate myself with, right? There are lots of these things where 802.11 is, by design, put themselves in a position where they define these things out of scope. And to me, those are the things where we have to get to some steady state. I mean, just like we made progress with simple interoperability problems of 8 years ago, I think fast forward, we might get to a point where, in some sense, lots of these issues have reached steady state, and we can take them for granted. And we're not there yet today. And until we reach that point, it's very hard because, we build all of these algorithms that are tightly coupled. In some sense, to me, the knowledge that I have in the controller that tells me something, we talk about, when we first started right from the beginning, Aruba has always had a stateful firewall in the controller. When I utter the word firewall, most people think of security. I mean, to me as a wireless guy, it's important for me to know what each packet is carrying. The classification part of it is extremely important. That way it allows me to manage my radio links in there, right? So that kind of tight coupling, it's very hard to do it in a vendor neutral way today. I mean, that doesn't mean we can't get to a point where it can happen, but it's still a few years away.
Abstraction and go with it, but it's going to take a lead.
You get a lowest common denominator and have that, and you have your value add when it's obviously single vendor.
Well, that was the idea with CapWeb, and that wasn't very successful. It's very hard to do that.
Right.
Mostly because the lowest common denominator was frozen in time. That was my argument in the CapWeb working group, that we just cannot stop work here. We have to keep pace with .11. As those guys start creating new things, we got to create support for that in this thing. But there was no interest in the working group, right? So I also recognize that it's a hard problem to solve today. But there might be a time, say 5 or 10 years from now, where we'll get to a point where we think some of those mundane things are in steady state, that we'll migrate up to more interesting problems elsewhere.
Decade. So you're going to because the wired network's going to bypass you, right? So you're ahead, clearly still are today, but the wired network's going to evolve. I mean, granted, wireless is the edge. I mean, we're not going to. The only reason we'll have an edge in the wired in the enterprise in the future is just to backhaul wireless.
Correct. I mean, in fact, we are at that point in many networks today.
Sure.
Right? If you look at the wired network, most of the traffic on the wired network on the access side is just tunnel traffic between a controller and an access point, and that is only going to, that the size of that is only going to increase, not the other way around. We agree, but I think.
But so is somebody that's willing to eat their own and kill their baby and fix wireless.
I think that that's where the wired guys are in quandary, right? It's very hard for Cisco to go in and say, okay, we can't do that. We don't have that legacy. We don't have protect anything in there.
Sounds like you are looking at it. It's cool. So can you get on beta now with OF APs?
Beta in a few months, not today.
Cool.
I know good parts of it are working in the next building there, in the engineering building.
Are you doing any EFTs yet?
Not yet. I mean, so I think we want to. So I am primarily
Are you discussing OpenFlow enabled APs or the solution he mentioned earlier, OpenFlow to the switch?
OpenFlow enabled APs.
Well, right now we are looking at, okay, what are the things that I can control, and I have the ability to control, and then over time, as more programmability becomes available, today we're building the solution with the assumption that we'll be able to program the intermediate network. That may not be true in every single.
So do you have OF enabled APs coming? That was his question.
Well, we have.
I'm not
OF-enabled controllers and APs. I mean, that's why going back to your vendor neutral thing, today it's because it's still tightly coupled. Even though our APs might be OF enabled, whether an OpenFlow controller can control the APs directly or go through the controller, that there may be differences in the semantics of that. But in theory, yes, we're getting to the programmability part of it.
Did anybody take wireless extensibility to? Is there a working group yet in ONF on that or anything? Or are you guys looking to get that dialogue started?
Inside of OpenFlow?
Yeah, at the ONF.
In fact, that is one of the things. In fact, yesterday I was having a discussion with a team. Is one of the things we have is, okay, the OpenFlow guys have done a good job of abstracting network nodes, but there's still gaps in there when it comes to wireless, or when it comes to the way we deploy wireless, where there's a controller and a set of APs that are being managed by the controller. Okay, how do I abstract this whole thing? Because there's some state over there and other state over here, but without putting them together, you don't have good states.
Are you guys part of the ONF?
We are, but we haven't. We are now trying to form our own ideas on what model makes the most sense before we go take it to the ONF and get it added to OpenFlow.
Cool, great. Are you getting into the wired market at all?
We have wired switches in our portfolio, but not, it's just still access switches. They are primarily there because there was a time when we had people come in and say that, when Aruba started, the security in Wi-Fi was severely broken. Right? There were open source code floating around that could break web keys in less than a minute and so on. These days it's less than 10 seconds. But the idea was, okay, as we built the security part of it on Wi-Fi, we suddenly found ourselves in a state where the security on Wi-Fi is much stronger than the security on wired. So we used to get questions on, can you also make the wired network secure? And we started building wired switches, but that was also the time it intersected with the introduction of the iPad, and the traffic started shifting that way. So we have wired switches in our portfolio that do selective functions, but we don't think it's just going to go occupy every single closet in every place. But we are, like our CEO says, when Aruba started, we were Aruba Wireless Network. Somewhere along the way, the wireless dropped. Right? We're still Aruba Networks. I mean, we do a huge chunk of wireless, but networking is in our DNA.
I'm just curious on the solution you showed. I know it was visionary with controlling the flows to optimize it, within anywhere in the network. From that design, what do you envision from a wired user perspective?
On the Bonjour side today, we actually have the wired network participate in that process as well. See, there's no reason why many of these constructs.
It's an Aruba switch.
Well, it makes it easier if it's an Aruba switch. With somebody else's switch, I need to work a little harder. That's where we did work with some of these vendors, where I can program a rule that say, don't propagate Bonjour locally, send it somewhere else, right? So kind of how OpenFlow works. We already are making progress where the wired network can participate in this whole process, and there's no reason why it's a wireless only solution. there should be no difference whether it's wired or wireless. It's just that on the wired network, my job is a little easier because that device is not going to move.
So what are you using? If it's not your switch, you're using just a Bonjour proxy service that runs as a virtual machine?
Today, well, in terms of what, the programming the intermediate network?
No, for the Bonjour discovery portion.
Oh, the Bonjour discovery. So the state is maintained, in our controller, or the same piece of code could run in another box, use, OpenFlow or other metrics, other protocols program the flow, how the packets flow around, right? So essentially, there is a central entity that maintains state on what do I know about the network, where are they located, who do they belong to, and such. And then I use those rules that somebody has told me to combine to construct responses to any requests that come in. That's how we manage what a user sees.
But the discovery process is easy. If you have the APs, discovery is easy for you in terms of the Bonjour services. But if you're on the Wireport side, because you decide to take your Apple TV and plug it in on the Wireport side, discovery is a little tougher if that's not extended into any of your controller fabric. So
right. So this is where I was saying, if it was one of our switches, that part is very easy because they naturally participate in this process.
Right. But I mean,
if it's somebody else's switch, we can program a rule that says, don't propagate it locally, tunnel it over there, right, to some central entity that maintains this Bonjour air group service.
Okay. I'm not quite following how you say program it there. What are you actually using on that?
OpenFlow?
Yeah, we can use OpenFlow or different people, like there's Open Daylight, and there's different people that have their own interfaces to program today. So today, there's all kinds of things around, and we can use any language that you want to speak to go in. And I just want to program a rule that say when you get an incoming Bonjour packet on one of your wired ports, don't
not there today. You're speculating what you might do in the future.
Well, we have the ability to do that on certain devices today.
How?
OpenFlow.
Isn't really there today in the campus.
Exactly.
Right?
I mean, that's why the certain devices come in, right? Some devices that allow us the ability to go make that happen. I can do that.
Right, so I don't know what LAN switches allow you to redirect Bonjour back into your controller.
What LAN switches do it today?
Right.
I mean, that's why the number of switches is very small today as a population.
HP Pro Curve.
Yeah. Okay.
That's one. Our own switches can do it. Arista doesn't have. They do have access switches sometimes that they use over there that we can again program a rule that says, don't forward it locally, right? Forward it only upstream in there. In the worst case, I can trunk these VLANs into the controller. That to me, it is not very efficient. It is not foolproof in the sense that I can still not control the propagation at the local switch, but it helps me with discovery at least.
Thank you. So when you're saying that you are propagating Bonjour packets toward your central controller, would your controller be an OpenFlow controller in this scenario, or would you just install a flow forwarding rule saying these packets go out that port?
Right. So whether the OpenFlow controller code sits within the controller or in an external entity, to us is kind of less significant.
Sure.
That's a deployment thing.
Yeah.
But we use some piece of code that can talk to the switch and push this rule down.
Yeah, so you effectively, from every switch, you need a VLAN or an uplink going into your controller.
That's the easier part, where if you just trunk all the VLANs to our controller, we'll naturally discover it. But the problem with that model is that I'm also letting it propagate locally, which if I want to control that tightly, I need to now tell this guy, don't propagate it locally, only send it over there.
Yeah, but you send it out on an outgoing port or on an outgoing VLAN.
Correct.
You're not tunneling it.
Correct.
Okay.
So wait, are you decrementing
Well,
the
you
TTL?
could tunnel it if the switch allows you to do that. So those are, again, mechanisms that we use to figure out the information.
So you're not decrementing the TTL on the...
No.
Okay.
You could tunnel it, you could just forward it onto a VLAN, right?
Yeah.
Just rewrite.
It's policy-based routing without TTL decrement.
Yes. Okay.